Today we're going to talk about midpoint and distance formulas. Our vocabulary for today is pretty short. We just have the coordinate plane, a leg, and a hypotenuse. The coordinate plane is a plane that is divided into four regions by a horizontal line, the x-axis, and a vertical line, the y-axis. The location or coordinates of a point are given by an ordered pair, x, y. You can find the midpoint of a segment by using the coordinates of its endpoints. Calculate the average of the x-coordinates and the average of the y-coordinates of the endpoints, and we'll see the formula on the next page. So here we have our formula. I know this looks like a lot of confusing numbers and everything, but really what you need to remember is that you have a point, x, y, and a second point, b, x, y. So we take our x's, we add them together and divide by 2 to get our x value, and we take our y values and divide them by 2 to get the y value. So you're really just averaging the x and averaging the y. And we'll do a couple of examples of this on the next couple of slides so you can see how it goes. Sometimes, to make it easier to picture the problem, plotting the segment's endpoints on a coordinate plane can help with the visualization of seeing where your point is. And once you get your answer, if you plot the midpoint, you can see if it looks like a reasonable answer.
Okay, now let's look at midpoint formula. I always think of the midpoint formula as taking the average of your x's and the average of your y's. So we add them up and divide by 2. So if our points are 6, 7, and 4, 3, we take our x values, 6 and 4, add them up, divide by 2, and then take your y values, 7 and 3, add them up, divide by 2, and those would be your two coordinates of your new point. So our new point would be 6 plus 4 is 10, divided by 2, 10 over 2 is 5, 7 plus 3 is also 10 over 2. So our midpoint of the line 6, 7, and 4, 3 would be 5, 5. Oftentimes your midpoint will also come out as a fraction, and that's okay. So if you take your x's here, we have 6 plus 7 over 2 and 2 plus 1 over 2. In this case, we have 13 over 2, or 6.5, and 2 plus 1 over 2 is 3.5, or 1.5. So here we have 13 halves and 3 halves, and those are going to reduce to 6.5, comma 1.5. So when you do a midpoint formula, if you start with whole numbers, you can either get whole number answers or answers with 0.5s.
The ruler postulate can be used to find the distance between 2 points on a number line. The distance formula is used to calculate the distance between 2 points in a coordinate plane. In a coordinate plane, the distance between 2 points, x, y, and xy is the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared.
Okay, let's look at an example using the distance formula. Say we want to find the distance from the point 2,4 to the point 5,8. So we have to use our distance formula. We'll take our x's and subtract them, so distance equals the square root of 5 minus 2 squared, those are our x's, plus 8 minus 4 squared. Okay, so we subtract our x's and square it, and subtract our y's and square it. So now we have distance equals the square root of 5 minus 2 is 3, so that'll be 3 squared, plus 4 squared. 3 squared is 9. 4 squared is 16. So now we have distance equals square root of 25. So the distance between those 2 points is 5 units. Okay, so we take our 2 points, we plug in x and y, and then solve to find that our distance is 5. Okay, here's a second example with distance formula. This one is not going to come out to an exact number, so we're going to go ahead and plug in our x's. We'll take d equals Square root 7 minus 6, subtract our x's, plus 1 minus 2. Okay, make sure they're both squared. So our distance equals square root of 1 squared plus 1 squared. Remember, the negative does not matter because if we square it, the square root of negative 1 squared is still going to be a positive 1. So distance equals 1 plus 1. So the distance here is equal to the square root of 2. If you use a calculator, that is approximately 1.7. But leaving it as square root of 2 is okay.
You can also use the Pythagorean theorem to find the distance between 2 points in a coordinate plane. A lot of students find that this is much easier. You will learn more about the Pythagorean theorem, however, in Chapter 5. In a right triangle, the two sides that form the right angle are the legs, so those are the two shorter sides. The side across from the right angle that stretches from one leg to the other is the hypotenuse, or the longest leg. In the diagram, A and B are the lengths of the shorter sides, or legs, of the right triangle. The longest side, the hypotenuse, has length of C. And most of you have probably seen the Pythagorean theorem before. We have in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse, or a squared plus b squared equals c squared. And you can see A, B, and C in your picture, and they're color-coded to the letters. So here's an example of finding a distance using the Pythagorean theorem. So say we want to find the distance from point 3, 4, which is up here, D, to E, which is negative 2, negative 5. What we do is we write some dotted lines showing the vertical and the horizontal, the A and the B. And then you count the squares. So if we're looking from point C to point D, we have a B of 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. So that vertical distance B is 9 squares, and our horizontal distance 1, 2, 3, 4, 5 for A. So we have A as 5 and B as 9. So now we can use the Pythagorean theorem to go ahead and calculate it. So A is 5, B is 9, so we do 5 squared plus 9 squared, 25 plus 81, which is 106. Take the square root of both sides to solve, and we find that C is equal to the square root of 106, and if we put that in a calculator, we get approximately 10.3. So a lot of students find this much easier to remember than remembering the distance formula, because the distance formula is a lot to memorize. Here's another example using the Pythagorean theorem. In this case, for A, we have 1, 2, 3, 4, 5, 6 for A, and B is 3. Plugging in A and B, we get 6 squared plus 3 squared, 36 plus 9, which is 45. C is equal to the square root of 45, so C is approximately 6.7. Go ahead and take a couple of minutes to try to fill out the lesson quiz. See if you can answer questions 1, 3, and 5 on the next page.